So welcome everyone to our PaaS Cloud Platform IoT course. My name is Jacek Kondratowicz. First of all, I will start from introducing myself. So this is my profile. I'm basically from Poland. I'm located currently in Gdańsk, where is one of our European office of ORing. My another office location is Irvine, California, USA, where I also support the North America market. I work for ORing in a position of technical business development manager. So basically I'm responsible for working with our partners from a more technical perspective. For my background, I have a Master of Science degree. I graduated from Gdańsk University of Technology in Poland in Industrial Control Engineering and Robotics. And currently I have over 6 years of experience in industrial communication market. And I work for ORing for over 4 years already. So let's move on to our agenda for today. So basically, my idea is to give you the basic information as a first initial step into the IoT world with ORing Cloud Platform and ORing solutions. This will be very basic information to create very good background for further solution development and initiate some good work with the university. And the agenda, first of all, will cover ORing PaaS Introduction. And then we'll move to our MQTT protocol overview. Another step we'll be discussing about ORing PaaS MQTT API. So basically how to connect any IoT device to the cloud platform to establish the communication and send the data. Next step will be overview of Node-RED software. So basically what Node-RED can do for you and how you can customize your own dashboard to visualize the data. And at the end of the presentation, I will show you a step-by-step configuration with Arduino. So basically how to connect Arduino with our cloud platform, how to store the data in the cloud platform, as well how to build a dashboard. And basically, if there is any question in the meantime during my presentations, please don't hesitate to interrupt me. We can have open discussion about each point. So if anything is unclear, let's just stop and answer your questions. Of course, we can have more open discussion at the end of the presentation as well. Okay, so if everyone is ready, let's move on to our PaaS introduction. So basically the idea of the cloud platform, so platform as a service, as PaaS stands for, is first of all to be very easy to use. So basically we want to have the possibility to very easy connectivity of devices to the platform, because when we are discussing about IoT, we are usually considering thousands, hundreds of thousands, maybe even millions of devices connected to one cloud platform. So we need to have a very user-friendly interface and very user-friendly configuration, which can help to connect all of these devices to the cloud. Next important key of the cloud platform is the security. It's always a concern when we are considering of sending very important data to the cloud platform. So basically, ORing Cloud Platform provides secured communications between the IoT devices and cloud applications. And the last key value is to be very flexible, because there are plenty of different IoT devices in the market, plenty of different applications, plenty of different cloud platforms coming from different vendors. So we want to be as flexible as possible to provide the possibility to design an application suitable for each project. So in this case, we are providing RESTful APIs, all the documentation, which helps the user to create their own applications and very easy connect the devices and design their own solutions for their projects. So let's stop for a while with this slide. So basically, it's showing ORing IoT platform architecture. So like always, at the bottom we have so-called things, right? That's why the technology is called Internet of Things. So things are the devices which want to be connected to the cloud platform for sending the data, monitoring and controlling purposes. These devices can be our networking devices like switches, like access points, but also many other devices being used in the factory floor, like sensors, like meters, like robots, even streetlights for smart cities applications. And these devices usually need some kind of a IoT gateway or the technology which helps them to communicate with the cloud platform. That's why we have the IoT gateway layer in this structure, where we can use our products and our technologies to establish the communication between the gateways, between the devices and the cloud platform. In this case, we can use wireless interfaces like cellular-based 3G, 4G, low power one, narrowband IoT, CATM1, or island sensing band LoRaWAN. These devices are usually responsible for converting the raw data coming from the things to the cloud platform language, which is usually a protocol. So moving a little bit up to PaaS layer, we have the southbound API of the cloud platform. There are some basic protocols currently supported in the market. These protocols are MQTT, and also including MQTT Spark Plug B version, which defines the payload and topic. There is also co-op or lightweight machine-to-machine. All of these protocols can be supported by our devices and our cloud platform. On the other hand, looking at the history of how these protocols were developed and how familiar people and customers are with these protocols, I will say that currently MQTT is the protocol which is becoming like a global standard for all IoT applications, and I think it's most commonly used currently in current IoT world. When we are discussing about the cloud platform functionality, so the cloud platform is usually responsible for managing the devices and storing the data. So in the cloud platform, you have features like account management, thing management, data analysis features, data logger, which helps to store the data safely and securely. We have the security management, AI engine, network management, rule engine, and any other features related to managing the devices and the data. And then on the top of the cloud platform, we have northbound API. It's RESTful API with OAuth 2.0 authorization method. And basically with this RESTful API, we can integrate many different applications which can then use the data from the cloud platform and, for example, visualize it in a readable, user-friendly way. In this case, ORing developed several applications that are currently designed from scratch by our R&D engineers. These are MagicCity, which is especially designed for smart cities application and controlling intelligent lighting systems. We have MagicCollect, which helps to collect information, collect data from different kind of sensors and end devices located somewhere in the field. We have MagicConnect. This is a feature and application which helps to establish VPN tunneling connection with end devices, which is secured, encrypted, and helps to control the end devices. For example, change the configuration or access the device remotely. Another application also included in our SaaS, so System as a Service, is a Node-RED. We'll discuss a little bit more about Node-RED later during next slides. And we have some SCADA systems also integrated with the cloud platform. But because we have the RESTful API documentation, we have the API which helps us to connect with different third-party cloud platforms. All of this provides the possibility to system designers to create their own ideas, create their own solutions, depending on the functionality they need. So looking from a PaaS architecture and service stack that we have in the offer, basically in the middle, the blue color, you can see this is the cloud platform which provides account management, thing management, and data management. We have southbound API with the protocols like MQTT, co-op, lightweight machine-to-machine. We have our open gateway feature in our devices, which helps very easily to establish connection between end devices and the cloud platform. On the left, you can see some example of our ready products for IoT, which are IoT gateways like IMG or IR series products. Then on the right, we have northbound API, so the RESTful API, which helps to connect helps to integrate different kind of cloud applications to the cloud platform. And now I would like to introduce these features in more details. So first of all, there is a things management, right? As I mentioned at the beginning, we also need to have the possibility to control and add the devices to the cloud very easily. So the cloud platform feature provides a possibility of very easy provisioning and a bootstrap server feature for auto provisioning of the devices. We have lifecycle management, real-time monitoring of the status of the device, configuration, and we can visualize the network topology. Next feature, very important, is data management. Because we are storing big data from many different types of devices, we also need to have some very useful tools which can help us to do this. In this case, our data logger provides possibility to store the data very safely and securely, so no one unauthorized can access this data. We have data analytics, machine learning features, and data visualization. Because raw data is not always helpful to understand what's going on in the system. Next, network management. So we have features which provides the VPN remote access to end devices, which is secured. We have remote configuration, so we don't need to send the service team to our devices to check its status or any failure. We can access the device remotely, which helps to save time and cost. We have over-the-air performance, so we can send the configuration directly from the cloud to the device, also including firmware over the air, so we can change the whole firmware of the device from the dashboard to the device. We have machine-to-machine communication with legacy protocols, like for example Modbus TCP, Modbus RTU, and the network topology view as well. Another feature is a rule engine. So this is very basic control, a very basic intelligence, which helps to change the status of the device based on some inputs from this device. So for example, there are rules like if, then, else, logical action, which makes the decision for automation. For the IoT protocol layer, basically, as I mentioned, we are also focused to provide the flexibility. So we have HTTPS, CoAP with DTLS, MQTT also with encrypted with TLS, also including Sparkplug version of MQTT, all to provide the possibility to connect different kind of devices. And because these are global standards, we don't, there is no necessity to connect only ORing devices to the cloud platform. If the user or other vendor can follow our API, it's very easy to connect third-party device to the cloud to store the data. IoT security, at the moment, we support TLS version 1.2. From the northbound API to authorize the applications connected to the cloud platform, it's OAuth 2.0 protocol. And of course, we have account management. So of course, there is system administrator who can gain the access to for the users who are using the cloud platform, and provide the access to different parts of the system. So no one unauthorized can change device configuration or access the data, for example. Then we have integration capabilities. So we have application management, device SDK, RESTful APIs, and all of this to provide the possibility to integrate different solutions with the cloud platform. And the billing system. So billing system is integrated because we want to have a very good sales policy for the cloud platform, very easy to understand. So it's also integrated with the cloud, where the user can actually provide automatic payment for keeping the account active. And that's the welcome landing page of our PaaS. It's www.paas.oringnet.cloud, where you can see the overview features of the cloud platform solutions. There is also access to the documentation page. And here you can register your new account. Okay, so now let's move on to MQTT protocol overview. And I would like to first of all answer the question, what actually MQTT is. So basically MQTT stands for Message Querying Telemetry Transport. And this is machine-to-machine or Internet of Things connectivity protocol, which I already mentioned is one of the most common ones currently in the IoT world. It's extremely simple and very lightweight, so it's saving a lot of bandwidth in comparison to older protocols used in older technologies used in the market before. It was designed for connections with remote locations where a small code footprint is required or the network bandwidth is limited. It's based on publish-subscribe method, which I will describe more detailed during next slides, how it works actually in practice. It's an open standard. It means that everyone can use it, and it's free of charge, of course. Another advantage of MQTT is that it's running over TCP IP stack. So there is a standard definition which is using existing technology. Some ports are reserved, which is port 1883 for standard connectivity and 8883 for secure TLS or SSL connection. And for the security, it's secured with the encrypted connection with technologies with standards like SSL or TLS. Detailed specs and protocol documentation can be found in the website, which is also shown right now in the screen. So for more details, you can always refer to this page. So the MQTT specification simply describes how to implement a message-oriented middleware and publish and subscribe infrastructure. It was originally designed for a real-time mission-critical SCADA solution with below design goals. So MQTT, first of all, have to simplify things in comparison to old obsolete technology. It's very easy to implement on very constrained devices. Constrained devices means that we don't need very powerful hardware to work with MQTT software. It's very efficient because it's using little bandwidth and footprint as possible. It's very stateful, which is required for OT-centric messaging. Stateful, it means that we are always sure that we can reach the device. We can check the device status in real time to ensure the reliability of the system. And it's open, so no vendor lock-in. It means that it's open global standard, so everyone can use it. Everyone can develop their own solutions based on MQTT. And at the moment, there are numerous products and solutions in the market today. So IT uses this technology extensively. For example, Amazon, Microsoft, IBM, Google, all are based on MQTT protocol, as well as ORing Paas platform. So in the MQTT architecture, we have client and server connectivity. So what actually client does for the connectivity? The client is responsible for establishing a stateful MQTT session with the server. So basically, the client decides when to want to connect to the server, and server is authorizing this connection. Client is also responsible for issuing a subscription to MQTT topics, only to the topics that it is interested to. So it means that not all information is sent to the client when it's not necessary. So only the data which is actually needed for the client is being sent, which helps to reduce the bandwidth used in the in the network. MQTT client is also publishing the messages as required, is acting on MQTT message received, and it's ensuring proper keep alive messages for the session state. It means that the client is always ensuring us and sending keep alive message to confirm it's still online and active. And then on the other side, we have MQTT server, which is also called a broker, MQTT broker. And the broker, a server, is responsible for authentication and authorization of connecting clients, establishing the MQTT session with the client, receiving all messages which are actually going in the network, and deciding where to forward this message. Then registering subscriptions, routing published message to subscribed clients, and is guaranteeing the order of the message sent, as well as monitoring each client's session state. So now I would like to explain in very simple example how the MQTT message flow looks like. So let's imagine we have a MQTT server and two clients which want to communicate. The client on the left, first of all, will like to connect to the server. So it's sending the connect request, server is authorizing it. And the same with the client located on the right. So in this case, when both clients are authorized, there is TCP connectivity already established and the devices can communicate. Now, because the communication is based in publish subscribe method, the first client on the left would like to subscribe to a topic, which in this case, for example, will be hello/word. And the client on the right will say, okay, let's publish some information to the topic hello/word. In this case, this will be a string value, which is hello from a client. When the client will publish this message to topic hello/word, MQTT server will receive it, and then we'll check, okay, is there any other client subscribed to this specific topic? In this case, server will process incoming message and look if there are any subscriber on specific topic. And if the server will find the subscriber, then he will simply route the message to the MQTT client, which is subscribed to this topic. In this case, the message arrived almost in real time to the topic hello world, and the payload hello from a client is received on the first client from the left side. This is very basic and very simple architecture, how MQTT actually works. But of course, there's always a security concern when we are discussing about sending some important information, especially to the internet, to the cloud. In this case, MQTT is not secured itself, so the standard doesn't define any security. But the MQTT is based on TCP IP technology, so it leverages all the advantages of TCP IP technology, which is used during the communication. So all the MQTT TCP IP socket connections are remote originated. So the advantage here is with regular TCP IP connectivity, when we are considering thousands of connections, we will have many different IP addresses, many different ports, which we have to control and manage. In this case, we need to work only with one port. There is no IP connectivity, so it's very easy to establish and very scalable. TCP IP is also using transport layer security, so TLS encryption. That's why the security is the connectivity is fully secure. So TLS certificates can be used to authenticate the client to server, and TLS is used to encrypt communications between client and server. And on the application level, MQTT protocol uses username and password for authentication and access control list. So no unauthorized device and no unauthorized client can actually connect to the server to get the data. Okay, and this because I already told you that MQTT is an open standard, so basically everyone can use it, and you can send whatever you like in the payload. To make it more easier, most of the cloud platforms, as well as ORing Cloud platform, is using JSON format to include the data in the payload of MQTT message. So JSON, that's why I would like to introduce you briefly JSON and how to use it and what's the rule with using JSON. So JSON is basically Java script object notation. So it's a data interchange format based on a subset of JavaScript programming language. It's also very lightweight, so it's a good solution for MQTT for sure. It's very easy for humans to read and write, and easy for machines to parse and generate. And its programming language is independent. So JSON can be used with Python, can be used with C language, it doesn't matter, because it's only a format of how to encode the data in the payload. And more details about JSON specification can be found on json.org website, where you can always refer for more details. But I would like to give you some key essential information about JSON and the syntax rule. So there are actually just 4 rules we need to remember. Data is in name value pairs. Data is separated by commas. Curly braces hold objects and square braces hold arrays. So we have an object on an array. Object is an unordered set of name value pairs, and object begins with curly brace from the left and ends with a curly brace from the right. And each name is always followed by a colon, and the values are separated by comma. An array is an ordered collection of values, just like that, and begins with a square bracket, ends with a square bracket, and the same values are separated by comma. And all you have to remember that JSON values must be one of the following data types. So we have a possibility to choose between string, number, object, which is JSON object actually, array, Boolean, or null. So to give you a practical example how the JSON message looks like, so we have an object called students, which includes an array, and the values name and value. Name is name, value John, name age, value 23, name city, value Agra. This is an example of very basic JSON text. So now I would like to move to our PaaS API. So with this basic information I just introduced it to you, I would like to give some practical information how this is related to our solution in the cloud platform. So first of all, our PaaS documentation can be found at this website that you can actually see right now in the screen. And you can browse all of the information regarding the authorization, API keys, MQTT connectivity, how to define payload, how to work with data logger. And there are all the details necessary for developing own solution. However, during this presentation, I will refer to some essential information from this website to give you the background for further steps with solution development. So first of all, MQTT connectivity. As we already know, ORing Paas supports MQTT protocol. Our broker address is mqtt.paas.oringnet.cloud, and we have two separate ports, which we need to remember. In this case, port 1883 is a standard port for not secured MQTT connection, and we have port 8083 with MQTT security. Next is a Think authentication. So Think is a representation of our device in the cloud platform. And for IoT devices, we use MQTT username and password for authentication. So after the device is registered, added to the cloud platform dashboard console, you will see that identity, secret, and client ID are generated randomly and automatically. So you don't need to define your own values. The cloud platform, our software will do it for you. And the MQTT client ID is in the format think, colon, $, and identity. Username is identity, and the password is always the secret. Our interface also provides some very user-friendly tools which helps you to copy these values from the console. So it's very easy to copy and paste later to your programming tools. For the topic and payload definition, as we mentioned, MQTT doesn't specify any standard for topic, namespace, and payload, unless we are discussing about Spark-Plug-B protocol version. However, today we are discussing only standard MQTT. In this case, we have an open way to develop our own solution and suggest how the topic and the payload should look like. In this case, we developed our own simple, efficient, and easy to understand MQTT payload definition, which helps to monitor the devices and collect real-time telemetry data. So the data topic is based on the pattern like you can see right now in the screen. So ORing Paas allows Think publishing telemetry to the data topic, and application can receive real-time data on this topic. So the data topic pattern is Think identity, data bucket identity. So for the payload format, we are always using JSON. In this case, the format of the JSON contains ID, value, and optional timestamp properties. So ID is the name of a metric, value is value of a metric, and timestamp is optional. it provides timestamp in milliseconds. And right now on the right side of the screen, you can see some examples of JSON string, JSON format, which is acceptable by our cloud platform and data logger. So for example, if you would like to see it to send temperature value from a sensor, it's ID temperature value 25.5. And now let's move on to our data logger. Once we already know how the MQTT should be built, now I would like to explain how to aggregate the data inside the cloud platform and how to let the data logger understand what is actually coming from the end devices. So data logger can collect, process, and store IoT things telemetry efficiently and securely. And we provide a RESTful API to make this data available for further analysis, which can be used, for example, by applications on the top of the cloud platform. And now to explain the rule, the data logger is based on data bucket and data shape. Data bucket is used to aggregate the data. So data bucket ID is related to MQTT data topic. So if the device is publishing the data, it should always publish it to the data bucket's ID. And data shape is actually inside the data bucket and is used for describing what kind of data will be present in the data bucket. So data shape ID is related to MQTT data topic payload ID property. Data shape must belong to one of the following data types. So string, integer, float, Boolean, hex, or maybe coordinates from GPS. And to give you the example, this is our topic, which is thing identity data, and sensor data is our data bucket. And in this data bucket, we have 3 different values like temperature, humidity, or PM 2.5. In this case, we are publishing the data to this topic with this ID, and helps thanks to this, the information from the device will be stored in the data logger. But you always have to remember that if the uploaded data doesn't fit to the data shape's name and the ID or data type, it will be ignored. It means that if you can't see the data, that's the first thing you need to start troubleshooting with. And that's our console screen from the IoT platform, where I open the data interface. You can see that from the interface, you can, with a drop-down menu, you can choose your bucket. In this case, my bucket is called sensors. Then if the bucket is chosen, you can choose your shape. In this case, it's temperature. The ID of the value is temp. You can sort your values, you can order them from new to old, from old to new. You can specify the time range you want to see the data. And after clicking the search button, you can list the data with current filtering settings. So in this case, you can see that the list contains the time interval, so the actual date and hour, and the time zone, and the value of temperature. So that's an example how the data logger works in our cloud. Okay, so that was the part for sending the data, the connectivity between end device and our cloud platform. Now I would like to move to the Node-RED part, an overview, to give you a brief idea how you can basically customize and build your own dashboards for data visualization. And ORing actually makes it quite easy for the users. But let's start from the beginning, from the background. What is Node-RED? So Node-RED is a flow-based programming tool. It's completely free of charge because it's open source. So basically, also anyone can use it for own information flow development, own projects. It's describing an application's behavior as a network of black boxes, so-called nodes. So it's so easy that you just need to use write block and use a drag and drop method to put it in a workspace. Simply connect the blocks and your flow is ready. After deploying it, you can already play with the data. It's based on the browser, and within the browser, you can create your application by dragging these nodes from the existing palette. And there is existing palette, but because the software, the tool is open, everyone, the community can actually design their own blocks for the components and use them in their own projects. So as I just said, the palette of nodes can be easily extended by installing new nodes created by the community. And you can quickly create a live data dashboard for visualization purposes. So there is also a palette which includes some components for the dashboard, like gauges, like charts, and anything needed for creating very colorful, easy to read data visualization, right? Like you can see right now in the screen as an example. And detailed specification and installation files are available on node-red.org website. However, the truth is that with ORing PaaS, you don't need any installation files at all, because Node-RED is already integrated with RESTful API on our cloud platform. It's working on our server. It means that the user doesn't have to install anything. It's ready, let's say, out of the box together with our cloud platform account, which I will show you later. So this is basically the screen from our IoT platform, which is showing the flow. It's just enough to open the website, and you can start to work with Node-RED right away. As I mentioned, there is standard component parents, so you can use your own workspace and standard parents to create the flow for the data. However, ORing developed and added ORing PaaS nodes for the Node-RED, which make it even easier to establish the connection between the end device and the dashboard. In this case, we have 3 nodes available. The first one is ORing PaaS Think node, the orange one, which you can see right now in the screen. And this node is already encoded to create an end-to-end connection between ORing PaaS application and registered Think. Another 2 blocks are for conversion the data to be readable for the dashboard components palette. In this case, we have ORing PaaS dashboard chart adapter and gauge adapter. And this output payload converts the Think node output payload into Node-RED dashboard payload. The components are available to download at below website, so you can basically install them very easily to your Node-RED. Okay, I think our timing is good. If there are no questions in the meantime for this, let's say, theoretical part, now I would like to more practical part to discuss about the step-by-step configuration guide with Arduino. For the starter kit that I used for my presentation, this is the equipment actually I have for the demo today, which is Arduino Uno Rev 3. I have ESP8266 module, which is a Wi-Fi module compatible with Arduino, and it's based on Vemos D1 Wi-Fi development board, which is quite easy to programming with USB interface. For the demo purposes, I want to show you some simple basic functionality of a temperature and humidity sensor, tact switch, and LED. And of course, I have some additional accessories like USB cables, connecting cables, breadboard, and resistors. So this is basically how the setup looks like, the connectivity. Everything is connected with each other. And thanks to this setup, my goal is to visualize the temperature and humidity value in the dashboard, use the tact switch to visualize its status in the dashboard, as well as provide two-sided communication. So I want to use a button on the dashboard to turn on and turn off the green LED, which you can see on the screen right now. So the devices which are used in the starter kit, so LED, temperature, and humidity sensor and tact switch, are connected to IOs in the ESP Wi-Fi module. And as you remember the ORing PaaS architecture from previous slides, this is the same slide which represents actual architecture of the live demo I will present today. So in our case, the things will be switch, sensor, and LED. They will use the serial and digital input-output interface with the ESP8266 Wi-Fi module, which in this case, our module will act as an IoT gateway. So it will help us to speak with the end devices and convert the data to the cloud platform interface, which of course in this case will be MQTT. Sending the data with MQTT to our PaaS will help us to use the data logger to store the information from our end devices and show the history of the data. And then on the top, we'll use our Node-RED to extract the data from the cloud and visualize its real status as well as a history, and provide some user interface, which also helps to control the end device, which is LED in this case. So for the configuration steps, I will show you just 5 steps that we need to have to establish the connectivity. Actually just 4, because the 5th step is already the final result of our work. So first of all, we start from registering a new thing in the cloud platform. Then we'll create an application on the PaaS. The next step will be building a dashboard in Node-RED. And then I will show you some background information about ESP8266 module programming. Okay, so let's move on to our first step. So once your account is PaaS account is registered, you can already start to register and add new things, new devices in the cloud platform. In this case, you have to go to the Think menu on the left and click the button with plus and create new device. The new window will pop up with Think information, data bucket, and configuration, where you need to put the information of your device. In this case, I use device name, model name, the serial number, which is in this case an example, description, which later will help you to identify your setup. You have visibility, configuration for private and public features. You have think type. Device is using standard MQTT. Ion is a node especially for MQTT Spark Plug B protocol. So today we are only focused on device think type. You can also put coordinates of your device depending on your location to use this feature to localize your device on a map interface. So during the registering new thing, you can already start configuring the data logger. Of course, you can always do it later, because you can add the data logger later and edit your data shapes and data buckets. However, during registration, it's also possible to create the data logger configuration as well. So in this case, because I already know what kind of data, what kind of values I will be sending from the device, because I remember that I have temperature and humidity sensor as well as a button, I created 2 data buckets. The first data buckets is sensors actually, and in this data bucket we have 2 shapes. The first shape ID is temp, and the data type is integer. The alias for visualization is temperature. You can always specify units. In this case, it's Celsius degrees. And the second shape is humidity, which shape ID is HUM. Integer, alias humidity, unit percentage. And the second data bucket is for the button control, which will also help us to store the information about the button status, if it's pushed or not. So the shape ID is but1, also integer, and alias is button1. There is no unit in this case. So after the device is created, as I mentioned before, the device will be automatically registered with its unique identity, secret, and client ID, which later can be copied to your application, to your programming tool, or the code for your device. So this screen shows the already registered new thing in our cloud platform, you can see it's activated, but still not online. So there is a gray dot on the left side of the name of the thing. After we will connect our device, this ground should turn green. Okay, that was the first step. Now we can move on to the second step. In this case, because we want to use the Node-RED and Node-RED ORing PaaS blocks inside the software, inside our workspace, we need to register a new application. These steps are also very simple. So just need to go to the application menu on the left, then use the plus create new button on the right. And this new window will pop up where you have to put information about your new application. In this case, I use the name ESP8266 Node-RED. Description, website is just a landing page if you want to open the application from external source. So in this case, it's only optional. And redirect URL is our local host port 3000. After the application is created, it will be registered with identity and the secret, but we still need the API key for security. So after we are sure we already need the key, we can click the generate button, and the API key, unique API key, will be generated. You always can revoke or renew this API key for some security concerns. If you, for example, you are not sure if someone else has the access to the cloud platform and could get the access to the API key, you can always renew it. However, in this case, we have three values, which is identity, secret, and API key, which later we'll use in our Node-RED node. So that was the step 2. Now step 3, which is building a dashboard. So how to actually work with Node-RED in practice. In this case, we are moving to our flow menu on the left. If you have already working project, you can use existing workspace. If you would like to create a very new workspace, there is a plus button on the right top corner, which you can click and change the name of your workspace. In this case, I created new workspace, which is called ESP8266 demo. The components palette is on the left. After the PaaS nodes are installed in this palette, they should already appear there. So as I mentioned, the rule is very simple. You just need to drag and drop the component to your workspace, then double click on it to change the configuration. So after double clicking the component, which is right now visible on the screen, which is ORing Paas thing, you will see such a menu. In this case, you need to give the app a name, app identity, app secret, and API key, which you can simply copy from the previous screen with your registered application. So when you put this information inside the Node-RED properties, Paas Think Node properties, you can update it, and actually it should be already registered. Then another property of the Think node is that you have to connect it with your specific thing inside the cloud platform, which we also created during the step 1. In this case, we have our ESP8266 demo thing. That's the name of our device, and we have its unique identity, which we also can copy and put inside the Think node properties. After it's done, the node should be already able to connect with our end device. But of course, it's not only about the connection, right? Because we still need to create the flow and use some components to visualize the data. Maybe let's start from the left side of the PaaS component, the orange one. So on the left side, you can see the switch, which is in this case called LED on-off. It's a simple switch which helps to generate information if something is turned on or off. Then we have a function which is transforming this payload to the payload needed for our Think Paas node. And on the right side, we are using our green blocks, also developed by ORing, to easily convert the information from the Paas Think node to the components from dashboard palette. So in this case, I'm using gauge and chart adapter, and I put some components which later will be visible, the blue components on the right, they later will be visible in our dashboard. In this case, you have a button, temperature gauge, humidity gauge, temperature chart, and humidity chart. So the gauge will show us actual real-time value, current last value from the sensor. On the other hand, the chart will show us the history, how the values were changed in time. So now let's go through the configuration of each block separately. Starting from the LED on-off button. So after double-clicking it, you will see the properties window. You can, of course, use the dashboard group where the component should belong to. You can specify its size, but it's not very critical and necessary at this stage. Label is how the component is called. You can choose the icon, and important thing during this configuration is on and off payload. So what actually this button is sending when you change its position. So in this case, I choose number, which is on payload is number 1, and off payload is number 2, which later will be also adapted in our Arduino program code, which I will show you. Moving further to our function block, after double clicking, you have to define the function which will return the payload from the switch to actual payload needed by our ORing Paas Think node. In this case, this payload is visible right now. This is very simple function, which is returning command ID. In this case, it's LED1. As you remember, I also added this value in our data logger. And we have a topic which is called LED command, which later we'll use for subscribing our device to this topic to get the command from the cloud. In this case, after the switch being toggled, the command will be sent to this specific topic. So we'll have Think. This Think ID, which you remember is already registered in the cloud platform, CMD, downlink, LED command. And the payload will look like this. So it's JSON ID LED1, value will be 1 or 2 depending on the switch position. And later we need to remember about this configuration, which will be used in our program in Arduino. Okay, moving further, how the ORing dashboard adapters work. You can see it's very easy configuration. There is no very extremely knowledge necessary, because all you have to remember are the IDs of the values put in data shapes during your Think registration. So in this case, we know we have a button, we have temperature, we have humidity. In this case, it's BAT1, temp, and HUM for the device ID, which is the value ID, which is used in the payload. Thanks to this, the adapter will automatically create the format for the palette component, which will be visible in the dashboard. So building the dashboard is also quite simple, because you choose your components, how you want to visualize the data. So as I mentioned, I've chosen gauges and charts. I put them on the screen, and I am using also the button for the gauge, which is in a donut type, to visualize the button status from our end device. In this case, I am grouping these devices to our dashboard group ESP8266. I've chosen the donut type, created button 1 label. You can play with some colors, the gradients. I've chosen black color if the button is not switched, and green color if the button is switched, so turned on. For the temperature gauge, you can always also choose the type of the gauge, create your label, create your units, value format, and how you would like to present the data. You can specify the range of the gauge. So basically it's based on the sensor specification. So I know that my temperature sensor range is from -20 to +60 Celsius degree. So this is the maximum range I am showing in the screen. You can always specify the color gradient depending on the way you would like to visualize the data. So in this case, I specified that from -20 to 20 range, it will be blue color, so cold. From 20 to 40, it will be green color, so acceptable temperature, for example, and the red color for everything which is over 40 degrees. For the chart, the configuration is even more advanced because you have more features to choose. Of course, you can always add the component to specific group on the dashboard on the screen. You can name the label of it. You can choose what is the type of the chart. You can see what's the range of the x-axis. So in this case, I'm using 5 minutes time interval to visualize all the data coming to the cloud platform for the last 5 minutes, but of course you can choose anything you need here. You can always specify the range of the y-axis. In this case, I know the temperature is from -20 to +60, so this is the maximum values I am visualizing in the chart. And of course, you can choose interpolation and some colors for the data for the charts visible in the screen. So after the components and all the nodes are already configured, you can move on to playing with the layout of the components on your dashboard. In this case, on the right side, you can choose the icon, which I marked in the red rectangle, and click the layout button to go to the screen, which actually in a very user-friendly way will help you to choose the location of each component on the screen, choose the screen size itself, of course, choose the component size. It's very, very easy, very convenient to use. So in just few clicks, you can design your own customized dashboard with the components you just added to your workspace. In this case, if everything is ready, you can click the deploy button, which will deploy the project to the production, and you will see the successfully deployed message. In this case, you can see that I still have an error on my ESP8266 PaaS block. The error is there because our device, our end device, which is in this case the module, is still not configured yet. So our next step in this case will be programming our ESP8266 module. Of course, I'm not going to show you the full program, how the loops works and so on. I would like to show you just essential information, how we created the code and what kind of libraries we used during programming to establish the connection and send these simple values of temperature, humidity, button status, and LED status to the cloud platform. So first of all, because we are using ESP8266 Wi-Fi module, we need to include the module library into our programming, which will which will be very helpful for establishing the Wi-Fi environment, the Wi-Fi configuration with the module. And the next very important library is PubSub client. This is Arduino client for MQTT and provides a client for doing simple publish subscribe messaging with a server that supports MQTT. Next library is Arduino JSON, because Arduino itself doesn't support JSON format. In this case, we need to use this library in version 5.13.5, which provides encoding and decoding functionalities to send the information, to encode the values from the cloud platform and decode them to our payload when we want to send the MQTT message. And because I'm using DHT sensor, it also requires its own library, which helps to get the data from the sensor, which is temperature and humidity in this case. And of course, for programming, I'm using Arduino IDE software, so the tool which helps us to create the program and compile it and upload to the module memory. So for the next step is establishing our configuration for connectivity. In this case, you can see the SSID of my Wi-Fi network, the password for Wi-Fi connectivity, and the marked part in the red is a part for establishing the connection with our cloud server. So you already know the server URL address, which is MQTT PaaS ORing.cloud. You know the port is 1883. So we are not using the TLS encryption at the moment. It's a simple open connectivity. So our server also uses the username and password for the identification, which is in this case device ID and secret, as I also introduced it before in my previous slides. And this is our topic for subscription to LED command. So think ID, CMD, downlink, LED command. Later, we are also defining some other values used in the program. Next step is establishing Wi-Fi connection. So with the specific library, we are beginning the connection with SSID and password. And then we are moving to opening the TCP socket and establishing MQTT connection. So the thing ID, MQTT user, MQTT password are the values used for the authentication. Next step is button status. So in this case, our goal was to send the button status only when it's changed. So we don't want to publish too many information with some specific time interval. We want to send the information only when the button status changes. So when the button is pushed or released. So in this case, we are using the JSON library and encoding the information about the button status from the digital input of the module of the port, and we are publishing this information to our topic, which is in this case the think ID, data, and buttons, because as you remember, buttons is representing our data bucket, and later but1 is our data shape. Another step is programming the sensor. So we are reading the humidity and sensor value also with the sensor library. We are also, again, encoding it with our JSON library to ID temp and value temp, for example. And we are publishing this information in a loop every 10 seconds to our topic, which is think ID, data, sensors. Another part of the program is decoding JSON message for LED control. So basically the flow is in an opposite way. So we are not publishing information to the cloud, but we are subscribed to the cloud to get the LED status and change the digital output status on a command from the cloud platform. So once the button on the Node-RED dashboard is being pushed, it will publish the message which we are subscribed to, and we need to decode it. In this case, this is the part of the program that is responsible for this, and is showing the LED on, LED off status on in our console, a serial monitor. Because I have this LED right now here next to me, but because I'm not using the camera, I can't show you that the LED status is actually changing. That's why we'll print the message in the console monitor. Okay, so once the program is compiled and uploaded to our module, we can run it, and we'll see after the MQTT connection is established, the status of our thing inside the PaaS console. We change its status to online. So in this case, the gray dot will turn into green color. When we'll go inside the data of this specific thing, we will be able to choose our bucket, in this case sensor, and for example, humidity shape, and see that the data is coming to the cloud platform, to the data logger every 10 seconds. I'm sorry. And then moving to our flow and Node-RED, you will be able to see that our ESP8266 demo node is already connected. And after clicking on the icon I'm showing right now on the screen with the red arrow, you can launch the Node-RED dashboard. And that's actually the final result of our job, our work. So you can see that we can change the LED status with the switch. You can visualize the real button status after it's being pushed or released. You can see some real-time values of temperature and humidity in the gauge. And there is a temperature and humidity chart, which is showing the history, how the data is changed in time. So that's the theory. So thank you for listening to my presentation. I will also would like to show you some live demo right now, because I have this starter kit right next to me. It should be online right now. So I hope you can still see my screen. I will simply log into our PaaS console and show you everything in real time, how it actually works, to give you some more practical feeling. So as you can see, I went to our PaaS ORing.cloud. I clicked the login button, and this is the main page of our console. We are logged in. There is a dashboard which is showing some information about device location, basic information about the connectivity rate, data usage, and how many things are registered in our system. We can go to the things menu. You can see that our ESP8266 device is still running at the moment, so it's online. I will open our Arduino IDE software to see if there are some messages coming in our serial monitor. So I will show you how the program is executed from the beginning. I will simply click the reset button, and we'll see all the steps of the program. So connecting to Wi-Fi, connecting to MQTT, and sending the messages every 10 seconds. So let's wait for a while. Yes, so you can see that we are reading the values of temperature and humidity. We are encoding them to JSON format and sending our encoded JSON format to MQTT server with specific topic, and the values are visible here. And the same when I will push the physical button right now on my breadboard, we should be able to see the status is being changed. Check. Okay, going now back to our device, our thing in the cloud platform. This is the information about the thing itself. So we can go to our data, choose our bucket, choose, for example, humidity, search for the data, the latest data. You can see that the latest data were published just a few seconds ago with exact timestamp and the information about the time zone, as well as there is a humidity value. So now if we will go to our flow, we should be able to see the Node-RED, which is installed, integrated with the cloud platform. So as I mentioned, you don't need to install anything. Everything is ready and integrated with your account. We can see that our ESP8266 node is connected. We can go to our dashboard and simply launch it. I will choose our group. Yeah, and now you can see the values are being published. So we have 22 Celsius degrees of the temperature and the percentage of our humidity. We can change the status of the LED. Okay, let me reset it one more time. Yes, so now when I push the button on the breadboard, you can see that the status of the button, right, in the dashboard is being changed. If I change the LED status, I am able to see that my LED is changed. I hope we can see the same message coming here. Yes, in the serial. We're changing the status. And here is our status in the serial monitor. Okay, so basically that's all I have to share for today. So if you have any questions, I'm ready to answer.